This is a podcast we're doing for the Cast and Steel 2026, making the Horseman's Act. And the Horseman's Act looks like it's going to be a really interesting project. One of the aspects of doing that is the technical report. And it's not clear to me the students really appreciate the value of the technical report because many of the judging categories require the technical report to give us insight into what it is they're doing. For example, on authenticity, how do I know that you've done the historical work? And how do I know that your Horseman's Acts really is consistent? Well, you need about a paragraph in your technical report with the reference of where you got the information from. So I know that you've done your homework and you know what a Horseman's Axe is, and you just didn't go on Wikipedia and see a picture and decide to do that. Same thing with castings. I don't know what clever things you did in making your casting. And if you don't tell me, or you don't tell me the obstacles you had to overcome, then I don't really have a full appreciation for what you're doing. So whether it's the best casting, the most authentic item, uh, even the performance testing, I need to know what you did and how you did it. So the technical report is really a critical item for that. This year, because we have so many students and because we got judges who are tired of reading through your aimless prose where you're just wandering around to fill up 30 pages, we decided to only give you 10 pages. But we really made it easier than that. You have 10 pages of text you can use. We're happy for you to include tables and pictures at the end or diagrams at the end. So your bibliography of references doesn't count in that total. The pictures that you want to put at the end or the other graphics you might want to use, that also is something that you have. You can add additional pictures because that doesn't weigh us down. So you really need to think through both how do you communicate how good your team was, how do you communicate your interaction with industry, how do you communicate how the project went, and how do you communicate the authenticity of your thing, how do you communicate what you learned. You've got to impress John Cory and especially that you love castings and you've thought about castings for him to think you made the best casting. I think Ken's a little more moderate than that, but John's pretty hardcore on that stuff. So with that, John, why don't you jump in there and straighten out what I've failed to tell the kids about the technical report that you think they need to know?
I think the biggest thing to know up front is that AI is the big thing, but it did not create your weapon. You created this process. It should be your report, not something that you try to get out of AI. You experienced all this. You should know what you went through and what happened and who you dealt with. To me, it's pretty simple to see that when the students are writing their reports out. Last year, we had several that were very good. The one area where I did see a little AI was in the historic sections. A lot of that was the same.
Oh, that's good. That's good. Patrick, you have been, why did we invite you as a foraging guy? Because you're really obsessive at reading these reports and thinking about them. It's remarkable to me. I guess foraging is such a boring opportunity that being able to read about castings is really exciting to you. But you read all the reports. What is it that you'd like the students to know, and what advice would you give them to improve their product?
I would say that the report is really the student's opportunity to demonstrate their understanding of the various things that they've done. Of course, that can come in a lot of different sort of subcategories. So it can be understanding of the history, like John just mentioned, of metallurgy, of the casting process, um, even of how decisions are made. Well, this is something I've seen in some reports that I've really enjoyed, is where they've included something about how did they decide on their design. Sometimes it's simply, oh, we're going to just go copy what we see on the internet, which is kind of boring. I mean, you can do it, and it still gives you an experience of making an object and getting to test it and stuff, so that like you still get a pretty good experience from the hands-on side. But if you engage your team members to each go out and do their own sort of review of available options and then come back together and discuss those as a team. And like, how did you then decide on what to actually put forward into manufacturing? Sometimes that might be what you guys were all excited about. Sometimes that might have something to do with limitations that you have in terms of resources to help manufacture. But as a reader, it's nice to know how you reached your decisions. And when I see teams that are using really good decision-making techniques, things that we would recognize in the industry as collaborative approaches that are systematic, I think it's worthwhile to recognize that.
Yeah, one of the things that's really, I think, not well understood, because a lot of the student teams treat this like the other student competitions where they think it's supposed to be an exploration of the talents and skills that they have individually. And we really want this to be like a high-end industrial project where you're going to use the best resources available. So you're going to call the smartest metallurgists you can find. You're going to talk to the foundry that's an industry partner. You may go visit a foundry right up front to see what it is. And one of the real challenges is, since we're doing cast in steel to show how creatively you can use the casting process, when you look at the design, if all you're trying to do is cast a historical weapon exactly the way it looked, you really haven't thought through what can I do with castings that they couldn't have done if they were forging it or using old processes. I mean, we've seen that with a lot of the items in the past where they'll use a truss structure or they'll have some way of lightening the material. They can put more modulus in by using geometry instead of just a steel bar. And so it's really interesting to me for them to really explore how can I use the casting process with its geometric flexibility and the ability to do different things? How can I use that to add value and just really create real performance and capability with that, beauty that way? So yeah, I think that's really key. So Ken, go ahead, shoot it to kids. Yeah, tell them what you like and don't like.
Um, One thing it's been a while since I was in a university, but I think this technical report is maybe the first time that the students are exposed to writing a technical report. And it's a way of communicating that you've met the customer's expectations. And there's, Raymond, you just mentioned that there's other competitions in universities. And I ran into one where the civil engineering departments are building a bridge once a year type competition. Which I see as intriguing. And this is an opportunity for college students now to demonstrate that they actually made something and they wrote about it. And that's something, they're working on a team. That's important. Let's see, they met the customer's expectations. And this is something they can put in their resume when they graduate. I think employers are going to look at this, and I look at this as an extremely valuable opportunity for the team members on participating in this competition.
Yeah, that's really good, because basically all communication between people is a story that you tell. And even with the ordinary forms and constrictions you have on technical reports, you really are trying to communicate something. It's things about your team, things about your project, things about your successes and failures. And so it's really important to not get too involved in sort of the technical talk or the institutional talk where you're just checking the boxes and using jargon, instead of really telling us the story of how did your team come together? How did you overcome challenges? How did you make critical decisions? And how did you try to fulfill all of the requirements? And so you may want to look several times at both the frequently asked questions and the interactions. Even go online and look at or read some of the old technical reports on our website and try and get some sense of how do I communicate the value of what we did in our project.
Yeah, Raymond, I like to see it kind of like a routing. You start off, what's your first step? Okay, we design it, material selection, manufacturing selection. Go into that, why you did that. And then say, okay, now we're at the foundry. We made a mold. How did we make it? Did we print it? Did we use wax? Tell us how you did that. Then go into the melting process, the cleaning process, heat treat process, NDT process. Tell us what you did in each one of those steps, and we're going to have a better understanding of how you really made this casting.
Yeah, and one of the things you'd want to do in that, of course, is include some personal anecdote and exchanges. So it's not just we came here and we had to do this. It was we came here and Sam said we're going to do that, but Bill said that's a stupid idea, and we talked about it and came up with a brand new idea. They combined both of their ideas. That's the kind of thing that you can put in that really makes it come alive when you're reading the report and gives you a much better sense of the capability and the integrity of their decision-making process.
Yeah, and problem solving was big. Last year, one of the teams had a height issue with their crane, and they explained how they solved that.
That's about part of being a part of a team. I know my kids both participated when they were in college. They participated in a team, and they ended up doing everything, and they really didn't work as a team. And this report is a technical report, is an opportunity to demonstrate, hey, we did debate, and it came up with a conclusion or a reason we did something as a team, not just one person's opinion or decision.
Yeah, Ken, that's interesting because, of course, you and I are of a certain age where our senior project was our project. There wasn't
Right.
a team. Yeah.
Right, exactly.
Yes, yeah, yeah.
One of the things that I've appreciated with some of the reports was when they provided good explanations of things that went wrong. You know, it's, and I'll even in my own evaluations, I'll have a spot to indicate to myself, did this team struggle with something, and did they overcome it or not? And I'm sure there's times when teams have challenges and they just don't include that information in the report. But I think for me, trying to assess what students have learned, it's helpful to see where they struggled. What did they, how did things not go according to plan? If they had a mold failure, John mentioned the one with the height restriction they had in the foundry they were working with. There's a whole host of different things that go wrong, and how do you recover? And that's quite interesting, and it's really encouraging when you see teams who were very proactive at getting started on the project as early in the academic term as possible to allow for potential things that don't go correctly, and they have time to recover, learn from the mistake, and still submit a tool that we can test in actual competition.
Yeah, it's probably worthwhile to have one or two people who are charged within your team of keeping notes of the things you're doing in progress and try and write down funny things that happened or challenges that you had to overcome as a way of really making the project come alive. I can tell you that when I talk to the students, oftentimes they'll say, I really wanted to make the Horseman's axe and compete in a forged and fire thing, and I wanted to do that and win the competition. But what I really enjoyed the most was I learned more in doing this project than I did in all the classes I've taken. And I really enjoyed the fact that I not only had to be creative, but a real problem solver because we constantly ran into restrictions and challenges that we had to overcome. And so that's a huge value to the students who participate, but it's one of the goals that we have is really looking at that. One of the things that I'm interested in is people think that castings have limitations. And so how do the students do enough background work to understand how to make the casting have the highest performance so that they can achieve the kind of high-end performance we're asking from something that's not easy to make as a casting? One of the things that is that Dave Paulite always puts back on me is he wants to make something that's easier to cast, but I've always seen that it was a huge benefit to making something that's difficult to cast because suddenly the students have to grapple with how do I manage this process to do something that's difficult to do?
So to piggyback on that, coming from the forging background and looking at the objects that you select each year, every single one of them are things that traditionally were produced by forging because it is an easier way to make a sword, a pry bar, an axe. Like many of those are just easier to make when you do it as a forging. There's certain challenges you just don't face when you forge something that's long and thin and skinny, like the Washington sword blades that we did last year. So when we put that responsibility on the students to do that as a casting, even though I have a professional passion for forging, I absolutely appreciate the great challenge and especially the joy that comes in seeing your item perform successfully. When you take on that challenge and you get it to work, that's super exciting.
Yeah, it's
Well,
one of the things that we've always seen in the cast and steel competition that I always thought was important is people think cast steel's like cast iron. It can't be welded. It can't have that high level of performance. So it really was an intentional thing to do things that were always made by blacksmiths to show that the steel we make as castings is just as capable.
That's one of the interesting things about the item you've selected, Raymond, is that it's real world. Like Patrick just said, that a lot of what you're asking him to make traditionally is a forging, and in the real world, the foundry industry is converting forgings to castings because it is more economical. And there isn't just one way to make things, but there are items that don't lend themselves to castings, and they stay as forgings or rollings and wrought plate type things.
Sure.
The other thing is, it's not just a challenge for the students. There are many foundries that don't deal in this type of product. When we were looking at the sword last year, long skinny thing, a student group's working with a foundry with a 50-ton furnace. There's a misconception there. So it is actually fun for the foundry people trying to do this with something that's difficult to make as well. We know it's difficult, but we love the challenge. And to be fair with Pat, I mean, he's wrecked a lot of good castings by forging them. So
we could go back and forth on that all day long.
Yes.
But also the students should understand this is a fun industry to get into. You can hear how we can joke and laugh with each other now. It's like you're a family, a club. We become very close as an industry. And part of it is for the students to get to know the people at the foundries they're working with, the other students in the contest, because these will be lifelong associates.
Yeah, one of the things that we really have a great benefit because of the large programs we have, if you should talk to all the judges. They are superstars in their field, and you really should talk to all of the judges when you're at the competition. But you can even reach out to the judges if there's somebody you see on a podcast or see on something and you want to know, you can send me an email. They can send me an email and they can contact because I really do think the challenge to being the best at what you do is to find people who are smarter than you are, that know more than you do, and make them a dear friend of yours so that they'll tell you the best stuff to do. And so it seems to me if I'm a student, I should really use this opportunity to meet the people in industry and in other universities to really try and optimize not only what I'm making, but also to have a blast, because making new friends with people who are smarter than you are is one of the most fun things you can do with life.
I think I'll piggyback on that particular point that you've just made, Raymond. So when I was a young person, probably in high school, my dad used to tell me, it's not what you know, it's who you know. And I remember him saying that, but I didn't appreciate it. And now, I've been in the industry for quite a while, and And in more recent years, as I've gotten to know you personally, and then, by extension, John and Ken and all these other fine people that you connect everyone with, my dad's statement is 100% true. And if a student can come to appreciate that at a younger point in their life and career than I did, even though I don't like back and go, man, I had a lot of mistakes or whatever, not so much that, but the opportunities that perhaps I missed out on or didn't come to me as early as they could have because I didn't perhaps prioritize building those connections. I was really focused on, just working in the shop and doing day-to-day metallurgy things, which was very satisfying, and I'm glad that I did. But for students who are participating in this, you can get a chance to build those relationships from, really from the point that even before you graduate, you have now a professional network and a network of not just your peers, but people who can be mentors for you throughout your career. Think about if you're a student and you get a chance to spend a little bit of time with John or Ken or yourself, and I'm picking on you guys because you're all older than I am. So now a student comes in and is able to,
ouch.
well, but from the student's perspective, if you can build a relationship with somebody who has 30 or 40 or 50 years of experience in the industry, think about the advantage that gives that young person.
Yeah.
Being able to draw on those people as they begin their own career. They have questions, technical questions, personal questions, career advancement questions. You have now a network of people who all want to invest in you. That's one of the things that I see with all the judges. They're all very passionate about investing in the next generation. So you can go to those individuals with your questions on anything, and they're going to give you a perspective that's informed by decades of experience, both professionally and life in general. What a wonderful resource that is to young people.
Yeah, one of the things that I tell the young people here is that before the creation of the world, God decided who was going to take the seat next to you at lunch in a conference you're at. And your goal is to figure out why. Why did God want that person to sit next to me? Do they need something that I know or something I have? And so I'm supposed to be generous and spend my time and energy trying to help them? Or am I so deficient there's something they really have that I need and I need to figure out what it is they are? And if you do that, you'll be surprised at how many people like that become lifelong friends because you really make a connection if you really see those as real opportunities.
Mm-hmm. The other thing I would mention with respect to the students is the opportunity to build relationships with their peers, outside of their own school teams. I know I've seen this with my own son Josiah, who I think, I don't know if Ken's met Josiah, but certainly the rest of you guys know my son Josiah, who had attended a couple of these cast and steel events while he was in high school. And he has built some relationships with some of the college students, and he continues to communicate with one young man in particular that they've become good friends. And geographically, we're not close together, but they share common interests, and it's exciting for them to share what they're each working on in their own projects and daily life stuff. And so that's another way for students to grow their network.
Yep. So Ken, you've made friends all of your career. How would you reflect on the need to really reach out and create that network?
Oh boy. That's a tough one. I working with a team is you're real close to those individuals and you're making decisions together. And reaching out to the more experienced people like you and like Raymond and myself and John. I know Pat's the youngest, but to learn from them because of the experiences that they've had. And when I was in industry, that was a hard thing to do. We didn't have the internet. We didn't have AI. So I'm afraid that personal interaction is being lost with AI now. It's too easy to Google a question and you don't know where that answer is coming from. But if you can develop a relationship with a team member, or like we discussed, or an advisor that you can draw from. I think that's a benefit that you don't get in your college education. This is really an extension that it could be life-changing.
So why don't we have one more last round to tell the students something about the technical report that you really think is critical or important that may be helpful to them. And then at the end, we'll vote on who gives the best piece of advice. Just joking. So, John, why don't you fire us off?
Okay, when I looked at this when it first came out, I saw one area of this casting that somebody could really shine and stand out on. I'm not going to tell you what it was. I want to see what people do with it, because if I say what it is, everybody's going to look at it. I want to see what group has this in their mind and thinks outside of the box. That is what I see as particular. The other thing that gives you a little boost in my eyes is when you get out and you have your job. Everything in the foundry industry is about money. So do a little cost analysis maybe on your product.
Yeah.
What's it? Because we do that every day.
Yeah. And one of the things that I would reflect on, John, is when I go to the universities, oftentimes their foundry lab was set up like a mini production lab so that they were trying to emulate an industrial environment. And coming from an R&D background, I said, that's really stupid. My costs are in the time that the team spends, not in the materials that they're buying. And so basically, I need to really optimize my true cost. And when you're really doing a big engineering project with a special item, the cost of production is relatively small compared to the investment you're making to have the optimum performance. So I agree with you that cost is important. It's just that the cost at a project like this is really in the time and energy that people spend.
Yeah, they don't have overhead either.
Yeah. So Pat, what's your last fire off?
I think I would just say to take the time to thoroughly understand as much as you can and then communicate that well. I think that, I particularly enjoy when students include physical metallurgy, microscopy. They talk about alloy selection and heat treatment. Those are things that I personally am interested in. Not every team's perhaps going to be able to do that because of the various resources and focus of their individual programs. But if you're going to talk about something, metallurgy, history, process, whatever you're going to include, try to understand that thing as thoroughly as you possibly can and make sure that what you communicate demonstrates that understanding. I've definitely seen some times where people talk about metallurgy, physical metallurgy, phase transformation types of things, and it didn't sound like they really understood what they were talking about.
Yeah. So Ken, what's your last thing? I've got one too. So,
Okay. I can't emphasize enough to thoroughly understand what this competition is about and what's been requested of you. Raymond has put in the information about the contest. There is a table here of technical report must contain. And I've done a lot of traveling, and 10% of the people just don't get the message. And I see that. I see that in the technical reports. I mean, right at the beginning, Raymond says you need to state what the mission statement is. And 10% of the reports just don't include that. But what it is a mission statement. And you will see that in industry. Every company has got a mission statement. And that's what this is. The competition has got a mission statement. So state it. The other thing that keeps missing is pictures. I mean, and the reports. I mean, I've seen several reports without a picture. So we did, as a judge, we don't even know that you made something. I mean, it's all words. And then testing. The competition, your product is going to go to the competition, and they're going to hack and whack and try and break it. So the question is, as a team with your product, have you met the customer's expectations? You need to state the weight and the length, and that's in the report must contain statement. A lot of reports don't include that, but then have you used the product the way it was intended? Have you cut a watermelon in half, or have you done inspection to verify that the product does again perform the customer's expectations?
Yeah. Oh, that's great, Ken. That was really the thing I was going to harp on is we had so many failures last time, and one of the judges wanted us to require NDT. And of course, I want to leave it open-ended on the one hand. On the other hand, why in the world would you bring a sword to a competition that you've never even hit anything hard with, which is
Right.
really problematic. The professors all want me to tell them exactly what the tests are going to be so that they can design the item to pass the test. And I think one of the real joys is it's supposed to do what that item does in real life. And so the test will not be unfair to that. And so I really do think it would be useful for them to go ahead and have a short section on how did I test it to make sure it wasn't going to break the first time I hit something. But the other thing that you mentioned really made me think. You and I would remember going on a trip when you were young and your parents giving you a camera with 2 rolls of film. You could take 24 pictures in a week that you could bring home, and you didn't know whether they were going to turn out because you didn't know how they would look. And so for people today not to put pictures into reports is just crazy. You used to have to, even in technical reports when we started, you couldn't put many pictures in because each picture would cost you more than $1 a page back when $1 meant something. And you go, yeah, this is crazy. So I do think pictures is an important thing. But the thing you said about testing and then doing some quality checks, polishing or something to make sure you don't have cracks, liquid penetrant, something to make sure that the item can function, I think is really something that you ought to include in your report as well.
Maybe I could add just 2 quick things. Often I'm in the position of doing the historical authenticity assessments, and the pictures are extremely important for that because I'm trying to get as much of my judging done in advance of the competition as possible. And so if a team fails to include a picture of their finished item, just like Ken said, I'm kind of handicapped in being able to perform that task as a judge.
The other thing is, I mean, Raymond mentioned it a little bit. When we are at the competition next April in Michigan, come talk to us. If you wonder, I see I didn't win the report. I'm not going to tell you everything you did wrong, but what I'm going to tell you is why somebody else has stood out a little bit. We'll go over some things. I'm your typical engineer. I have spreadsheets. I take notes. I think Pat does the same thing.
I do.
Ask us. We're here to help you. We really are. We love this business. We love the competition.
I remembered my second point, which was on the testing. Raymond had said how professors would love to know exactly what we're going to do. I think if you watch any of the videos from the last 6 or 7 years, even though the testing's a little different each time, it's always aggressive, right? Whatever it is, it's always aggressive, and it always fits the intended use of the item we've asked people to make. So even though you don't know exactly what we're going to do, you can get a pretty good idea of what you should be able to do just by watching videos from previous year's competitions.
Yeah, in designing the tests and working with David Baker and Ben Abbott on the testing, my goal is to have the first 2 tests be a genuine test of the utility of the item without being too stressful to the item. We're not trying to see the limit of its capability. We're just trying to see that it actually functions the way that item is supposed to function. And then when we reduce it down to the finalists, that's when I'm happy for us to have some really critical tests where it really will challenge the integrity and the capability of the item to survive in some of the more aggressive environments it's in. So that was really it. It's sort of like the Cub Scouts, right? You want everybody to have at least 2 runs down the Pinewood Derby without making it all the way to the end so they can feel good about it. But at the end of the day, you really do have to do an aggressive enough test to really distinguish between the ones that perform well and the ones that perform adequately. Yeah.